Hi students, let me give some important questions regarding gravitation. Now what is gravitation? As you all know, the force with which the earth pulls the object towards it. The force with which the earth pulls the object towards it is called as the gravitational force. So it is a force experienced on the earth, okay, anywhere on that. Now on that basis you have very important question. What is universal law of gravitation? Derive the formula for it. Universal law of gravitation. What is universal law of gravitation? The universal law of gravitation states that the force between two bodies, okay, the force between two bodies is directly proportional to the product of their masses. The force between two bodies, okay, the force between two bodies is directly proportional to the product of their masses. See, force between two bodies is directly proportional to the product of the masses and inversely proportional to the square of the distance. Actually, this only can be written in the form of definition. See, the force between two bodies is directly proportional to the masses of the two bodies, or we can say directly proportional to the product of their masses and inversely proportional to the square of the distance. As the distance increases, the force decreases. Mass increases, force increases. That is the meaning of directly proportional. And on that basis you have this derivation. In the first page of the textbook itself you get that derivation. Consider two bodies having masses m1 and m2, having masses m1 and m2. Then the distance, let the distance be between them, let the distance between them be equal to d. So we know force is directly proportional to the product of the masses, right? So F is directly proportional to m1 and m2. This is first proportion. This you have to write it. Force is directly proportional to the product of the masses. Then second you will write inversely proportional to the square of the distance. So F is inversely proportional. Inversely means always it will be 1 by d squared because square of the distance. This is the second one. Now combining 1 and 2, from 1 and 2 we get F is proportional to m1 m2 divided by d squared, okay. And then this one we change it into constant, that is equal to. When we put equal to, we have to put a constant, and that is gravitational constant g, because it is all governed by this, or it is ruled by this gravitational force. So F is equal to g m1 m2 divided by d square, and where g is calculated as 6.67 into 10 to the power of minus 11 Newton per meter square kg square. Okay, so this is what is the universal law of gravitation. Very important question. The second question what they ask you here is, what is the value of g? They ask you what is the importance of law of gravitation. Okay, what is the importance of the universal law of gravitation? Now this also is there in the textbook. The importance is that the force that binds us to the earth. This is also very important question. Force that binds us to the earth. Then the motion of the moon around the earth is because of gravitation. Then planets which is moving around the sun, that is also due to the gravitation force. Tides, what do you mean by tides? Sometimes the water level will increase, sometimes the water level will decrease. That we say as the tides, the rise and fall in the level of water. That is also due to the gravitational force. And the flow of water is also due to the gravitational force. So if you remember any four of these, I think it is there in the textbook. Force that binds us to the earth, motion of the moon around the earth, motion of the planets around the sun, occurrence of tides, and the flow of water. Okay, this I am not mentioning it, you can refer it, but it's a very important question. What is the importance of law of gravitation? Okay, next, what is centripetal force? What is centripetal force? Now centripetal force is the force which is acting towards the center of a body which is moving in a circular path. Suppose you are standing here holding a stone tied with the help of a thread and you are rotating it over your head. So you observe, see, just think of it. When you are rotating it over your head, you are trying to pull it towards you, isn't it? See, you always try to move, but you're trying to pull it towards you. So that force is that force which is acting towards the center. So this force is responsible for changing the direction and also the velocity of an object. So simple I want to say is centripetal force is nothing but the force acting towards the center. Force acting towards the center. Force acting towards the center, okay, of a body moving in a circular path. Moving in a circular path. That is called as the centripetal force. Okay. Now let's come to the question on this. Then what is next one? What is free fall? Next question, what is free fall? So free fall is nothing, objects which will fall. If you throw an object from up, it will fall down very easily, isn't it? So that means they are falling towards the earth because of earth's gravitational force alone. They are called as free falling objects. So what is free fall? When objects fall towards the earth under the influence of the earth's, I am writing gravitational force, I am writing in shortcut, gravitational force, this is called as free fall. Okay. Then the next important question is, what is acceleration due to gravity? Acceleration due to gravity. This is denoted by the small letter g. Now whenever an object falls towards the earth, there is a free fall. So when an object falls towards the earth, these answers are there in the textbook. I am referring the textbook and giving it to you, just slightly changing it. And when an object falls towards the earth, okay, and acceleration is involved, isn't it? They have a certain speed, they will move down with a certain speed. That's acceleration is involved, and acceleration is involved. And this acceleration, why it is due to? Because of the earth's gravitational force. This acceleration is due to the gravitational pull, isn't it? That gravitational force is pulling that object, the gravitational pull. Okay. And that is why, since this acceleration is due towards the gravitational pull, it is called acceleration due to gravity, denoted by the letter, it is denoted by the letter G. Okay, it is denoted by the letter small g. Okay, now we know that the SI unit of g, it's denoted by g, and SI unit of g is same as that of acceleration. It is meter per second square. Okay, now we have we'll see what is g equal to now. Okay, derivation of g equal to, how do we get? Now g is equal to, see, now we have F is equal to what? Gravitation, mass 1 mass 2 divided by d squared. D means what here now? I will write it as r squared. D or r squared. Why? Because see, this is the earth, this is the center of the earth, we are on this, right? We are on this. So what is this height? This is the distance, this is radius, isn't it? This is the center of the earth, this is the earth's surface, we are all on this surface. If you are going at a certain height, then we say r plus h. Means if I am here, I am not on the surface. But if I am on the surface, we are all standing on the surface here, we take it this r and this is r actually. But if you are at certain height, then we take r plus h. Otherwise, this is simply radius, r. Okay, so instead of distance, I will write it as r. Now, from the second law of motion, F is also given as mass into acceleration, isn't it? Force is equal to mass into acceleration. Now, if I combine this is also force and this is also force, correct? Second. So, from 1 and 2, see, both being equal, we write GMM divided by r square is equal to MA, correct? Now, what we do is, this M and this M gets, because when it comes here, it comes down. So, this M and then this M gets cancelled. Okay. So, we get, now this is F is equal to MA I forgot to mention F is equal to ma, but now this acceleration, we are talking about acceleration due to gravity here. We write F is equal to m into g. Okay, I'm sorry, m into g. So now from 1 and 3, we have mg is equal to mm gets cancelled. So g is equal to gm divided by r square. So here they may ask you a question as, what are the factors on which, or what is g independent of, what is g independent of, or what are the factors on which g depends on, what are the factors on which g, that is acceleration due to gravity, depends on. So acceleration due to gravity depends on what? Depends on g, that is gravitation, mass of the earth, and also radius of the earth, that is distance, correct? It is independent of, it is independent of, remember this is a very important question, it is independent of the mass of the object. Remember, it is independent of the mass of the object. And the value of g, the value of g is less at the equator than at the poles. This is another question, than at the poles. Why? Give reason. It is because the earth is geoid in shape. Shape of the earth is geoid. Earth is geoid in shape, that is flattened at the poles, okay, and bulged at the equator. Earth is flattened at the poles, so radius is less at the pole, or radius of the earth is less at the poles than at the equator. Bulged at the equator, okay. Flattened, it is like the laddu flattened. See, here it will become flat and here it will become bulged, so radius becomes less. So height, okay, depends upon that, and bulged at the equator. Okay, now you have the equations of motion. Already you had the equations. V is equal to u plus at, v is equal to u plus g at, s is equal to ut plus half at square, and v squared minus u squared is equal to 2as. You had already. So now everywhere in place of a, you will be replacing it by g. Okay, we'll solve some of the problems, okay, regarding the gravitation sums. Okay, next one, what the question will be asked is, what is weight? Okay, difference between weight and mass. Okay, weight and mass. Now weight is actually mass into gravity. So if it is independent of gravity, then it is called as mass. That means mass is nothing but, mass is the total content of the body. It is the total content of the body. Okay, total content of the body. What it contains, total what it contains. Okay, that is total content of the body. Remember, it's a scalar quantity. It's a scalar quantity. And SI unit is kg. SI unit is